Welcome everyone to today's Space Syntax Lab seminar. It is my pleasure to welcome Dr. Onur Tümtürk, who will talk about his ongoing research on urban form and physical change. Onur is an assistant professor of urban design and morphology in Turkey, and he has completed his PhD at the University of Melbourne in 2024, where he established his expertise in exploring the intricate relationship between urban form and socio-spatial processes through morphological and spatial analytical lenses. His work, which bridges urban design, urban morphology, morphometrics, and socio-ecological perspectives, has been recognized with the 2022 Doctoral Academy Fellowship from the Melbourne Centre for Data Science and the 2023 Barra Dave Prize from the Melbourne School of Design. Today, he will be sharing insights from his recent research on urban form and change, insights on urban form evolution through configurational morphometrics, which examines how configurational properties, rather than geometric measures alone, explain patterns of physical change in urban environments. And this work has been in part published in two very nice journal articles focused on measuring the impact of plot types on physical change, a diachronic analysis of urban form evolution in New York, Melbourne, and Barcelona, as well as the impact of urban form on physical change, a quantitative and diachronic analysis of urban form evolution in Midtown Manhattan. And I will provide links to these two articles in the chat during his talk. And before I hand over, if you have any questions during the talk, please put them in the chat so we can address them at the very end at our Q&A after the talk. And with this, I'd like to hand over to you, Onur. The floor is yours.
Thanks, Simon, for this excellent introduction. Good afternoon or evening to everyone. Thanks again for inviting me, for having me. It's an absolute pleasure to be sharing my work in Space Syntax Lab seminars. There has been, I guess, lots of colleagues in this particular lab conducting this similar type of research that inspires my own latest studies. So it's great to be here. I will talk about the relationship between urban form and change, or in other words, how urban form conditions facilitate or hinder the possibility of change by relying on my recently completed PhD at the University of Melbourne. So I have to acknowledge Melbourne School of Design's generous support in conducting this research too. It will be a compact and brief presentation, I believe so. I will frame the topic by presenting a few current studies looking at the urban form and change relationship and trying to concretize the particular knowledge gaps that I'm addressing. And I will mostly discuss the methodological framework by revisiting my PhD. And I will discuss the findings by relying on these two distinct articles, which are lately published in Environment and Planning B and Cities. And I'm hoping to discuss the last part all together with you, like towards an evidence-based, time-conscious urban design supported by urban morphometrics. So the site that you see on the screen is central Melbourne, and a short comparative transition is illustrating how that form of the CBD changed after the 1940s until today. You may realize that some areas are dramatically different from what we observe in 1940s, like the high-rise building typologies are like a relief, showing where three-dimensional change mostly occur. And but it is highly possible at the same time to observe what kind of qualities are persistent. Even the form of the city changed a lot. We still have an overall understanding that it is still Melbourne. So as we all know, change and persistence are very key and vital terms, which are working in an interplay. And most importantly, the current urban form that we have is essentially built on top of the past urban form. Obviously, that is the contextual aspect of any design or planning process. Nothing occurs in tabula rasa, or rarely occurs in tabula rasa. If you are not creating something from scratch, it is always bounded with what is existent on the ground. So we can argue that past urban form creates some structural and formal preconditions for our future design choices and spatial possibilities. And our current choices are always bounded with these previous stage. And so there's a reciprocal relationship between these two ends. From this point onwards, my thesis and latest studies basically aim to understand this reciprocal relationship by asking how existing urban form conditions affect future spatial dynamics, and are there certain and specific conditions that may affect the rate of change and persistence in urban space? And if yes, can we measure this relationship with some reproducible quantitative approaches? And of course, this is a very central question of urban morphology, but in my opinion, a question that has been asked rarely compared to some other questions. I will open up this point a bit further in the following slides. So I guess briefly we can describe urban morphology as a field which aims to understand the relationship between form and change, a field aiming to develop some autonomous theories of form and change and describing how form patterns are changing. Some well-known literature summarizes the key components of morphology as form, resolution, and time. Form is basically described via these nested elements such as buildings, plots, urban blocks, streets, and maybe urban tissues at the largest scale. And resolution describes this color and nested relation between them. And time helps us to look at how these structures evolve over time. I always find Gaultier and Gilliland's metrics quite effective to position myself and the questions I asked. Briefly, they discuss distinctive approaches in urban morphology. At one end, there are studies adopting externalist approaches, and these studies are usually arguing that form of cities shaped by some external factors. And there are opposite approach arguing that transformation of form can be explained with its inner qualities, such as geometry, configuration, and topology. Obviously, like any conceptualization, it's a bit reductionist. I accept that. I mean, perspectives are not usually that much sterile, let's say, but I can say my research sits in this top left corner, like it is internalist and adopts a descriptive perspective far from being normative. I guess space syntax studies could be rightfully positioned in this corner too. So I'm basically trying to understand, not prescribe some normative positions. And I had studied the internal logic of urban form, like external conditions such as history, culture, socioeconomics are also important. But from internalist point of view, these variables are already reflected in the nature of the urban form. So I'm basically trying to find the reason of capacity for change or persistence in the form itself, like by looking at the measurement and geometry of the urban form. And I guess, a few years ago in Urban Morphology seminar in 2021, Meta Berghauser-Pont further zoomed into that specific top left corner and created another matrix that I like. Basically, the study is trying to understand the relationship between form and processes by using geometric or configurational approaches or descriptions of urban form. Within this new matrix, I can say that my study sits at the center of this second matrix. It encompasses both geometric and configurative descriptions of urban form, and it aims to understand the relation between form and processes of physical change. And one of the aims is to understand which type of descriptors are more reliable in explaining these processes, because what I realized, the geometric descriptions are usually used a lot in specific sort of studies trying to understand form and change relationship. And one of the aims is to compare their, let's say, consistency or reliability in explaining these processes. Like I said, this study has been conducted at the University of Melbourne. The aim was to develop a quantitative and diachronic framework and also an empirical support for the influential role of urban form on change and persistence. I Did an extensive review on studies focusing on the relation between urban form and spatial change, although it is kind of impossible to share this extensive review as part of today's discussion. I can say there are some particular knowledge gaps. The first one is lack of diachronic studies. These type of studies are extremely scarce compared to synchronic studies. One reason, obviously, is that diachronic research requires more time and effort due to its nature. And I guess another important reason is the scarcity of truly longitudinal morphological data sets. And I should also note that the difference between studies investigating growth of urban form versus change of urban form. I mean, growth is widely represented in this genre of studies, but these studies are mostly interested in the growth in extent or the coverage of urban form or street networks at larger scale. So they are leaving the finer grained components of urban form, such as plots or building footprints, underrepresented. So this is another gap in this current field. And I can also say that there are obviously very influential and fundamental studies providing valuable understanding on urban form evolution. Most of the historical geographical school of studies, starting with obviously Consent and British Morphology School, provide ample historical qualitative and usually single case studies, or Moudon's empirical research on Alamo Square creates a foundational moment for this type of research. Although they are highly important and valuable, they are highly qualitative still. I mean, does not offer reproducible and quantitative frameworks, which is kind of essential to produce evidence-based and empirical insights about the relation between form and change. And most of our current understanding usually stems from these historical qualitative studies at the moment. And supporting this further, a recent systematic review by Martin Fleischmann and his colleagues indicated that there's a much broader gap in urban morphology studies, showing that 95% of quantitative urban form studies are synchronic. They are not interested in change. So there's a mismatch here. I mean, most of the quantitative studies are not very much into change or the dimension of time. On the other hand, our understanding mostly stems from historical qualitative studies, but they do not offer quantitative frameworks. So these gaps leave a few dozens of studies explicitly focusing on urban form and change, like 15 or 20 different studies that I in detail examined in one of these recent articles. In this Environment and Planning B article, we criteria-based reviewed them to look at whether the relationship between form and change was described via quantitative measurement, or whether it was provided with numerical graphs and charts, or is there a systematic statistical analysis or not. And I can confidently say that most of the research are far from, I mean, truly being quantitative. And another limitation is about the context of these studies. It was remarkable to see that most of these studies are particularly conducted in either suburban settings or in historical medieval cities, like in Conson's case. So there's not much research investigating let's say, modern, highly dynamic city centers and so on. There's a contextual gap as well. And lastly, another probably the most important limitation is the variables used in these studies. Most of these studies predominantly rely on geometric descriptions. And when I say geometric, it means it is looking exactly the size or the shape of individual urban form elements. Let's say a shape of an individual plot, or size of an individual plot, size of a building footprint. Only a few studies, like for example, Professor Laura Vaughan's or Terma's studies adopting space syntax methods and naturally configurational approaches, I guess, as part of their adaptable suburbs research in the previous years. But there are recent innovative approaches, particularly emerging from Chalmers School of Architecture in the name of place syntax, which introduce configurational plot or building measures, like accessibility-based measurement of urban form. And these and their performance on measuring urban form and change has not yet been covered. So that was one of the aims of this study too. And addressing these limitations, I've developed a multiple case study framework consciously focusing on 3 comparable but highly different city centers to improve the generalizability of the results. Each cities are selected from distinct geographies: New York, Melbourne, and Barcelona, and all of them are kind of established at the first half of 1800s. They have comparatively different pace of developments. Like New York is urbanizing quite extensively. On the other hand, Barcelona is mostly conservative and stable in terms of the form and morphology. And within their boundaries, they have enough structural and formal, let's say, diversity to allow analyzing how different urban form conditions affects the change. And another reason is they have rich data sources, because the study is highly dependent on, available cartographic or morphological resources. And for the analysis, the most central locations of each city has been selected as the case study area, considering that, their most dynamic parts are these areas. And since they are the first established locations, they are the most changing locations in diachronic sense. In order to include the effect of surrounding context for the analysis, an extra 400 meters buffer zone has been created, because in the later slides, you will see that I will also employ some excess-based measurements, just in order to, prevent the edge effect, a potential edge effect. And each selected area is approximately 2 to 3 kilometers square, and with the buffer, it is more than 5 kilometers square, a good coverage of 3 cities. And if you consider that it will be a longitudinal data set, its coverage is kind of multiplied by the time frames that we repeat the analysis. So, and the definition of the temporal boundaries is also important. Starting from 1800s, each city has been mapped for each 40 to 50 years, depending on the available cartographic resources. The first detailed cartographic documents, I guess, started around 1880s and respectively 1920s, mid-century, like 1960s, 70s, and today's conditions. And these periods also correspond important transition periods for each city, from let's say industrial to modernist era, then postmodernist, and today's contemporary conditions. Data sources are multiple and quite extensive, but for the ones who are interested in, they are usually open access archival resources. I believe only for Barcelona, some of these resources were kind of buried in the archives and required me to go there personally and dig them a bit, like for later digitalization. The database basically includes 3 distinct urban form elements: street network, plot, parcel configuration, and building composition. The information of floor numbers are coded for each building footprint for the density analysis. And I should say that it was a meticulous but quite laborsome process of manual digitization. I still cannot believe myself how I decided to do that, but sometimes I guess you have to make your hands dirty a bit. At first, the idea was training some sort of an AI model to segmentize or digitize these cartographic resources for us. But the changing language of each map, not only, I mean, from cities to cities, but also from period to period, make it this type of task a bit, let's say, inefficient. So I adopted a kind of manual digitization process. Functional distribution is out of the context of today's talk, but especially for New York, it was quite possible to trace even the evolution of programmatic distribution as well. So the geospatial database is quite comprehensive and shows procedural transformation within each category of urban form element or function. I have measured urban form by relying on a series of quantitative urban form descriptions synthesized from an extensive literature review. For each urban form element, I have different set of variables nearly half of it geometric descriptions, like I said, and the other half is configurational descriptions. Although it is impossible to go one by one, I guess briefly I can say for plot measures, they are essentially focuses on geometric qualities such as size, shape, compactness or regularity of the shape, frontage, like narrowness or broadness of the plots. For building measures, they are interested in two-dimensional build coverage and three-dimensional density measures like well-known FSI and GSI measures. And street measures are adopted from obviously space syntax studies, focusing on closeness and between centrality to measure the degree of integration or the degree of Thoreau movement for a street segment. And this part is important as I included some novel descriptions coming from Chalmers School's place syntax studies, like colleagues of Lars Markus, Meta Vergazer-Pont, and lately Evgenia Bobkova's studies. Their place syntax method is important as it translated conventional geometric descriptions into configurational ones from accessibility point of view. For instance, instead of looking at the individual sizes of each plot, as you can see on the left-hand side, top left, we can look at accessible plot density from each origin plot within a given catchment, and that describes the overall granular quality of plot pattern, not individual plots. So it helps us not only looking at the individual qualities of individual plots, but looking at the overall plot pattern by relying on the accessibility provided by the street network. So these access-based measures are sensitive to contextual circumstances. They are not isolated measures like geometric variables. Same approach can be applied to buildings as well, like accessible floor space index, accessible ground space index. And street measures are already by nature configurational. And the next step, how I define and identify physical change. And physical change is over here described by building demolishment or new constructions in an iterative sense by comparing each subsequent period with each other. I identify where physical changes occur and which parts preserve their quality and persist between each analysis period. So it results in a binary information of change or persistence, like 1 or 0. And that information is stored at the plot scale for each time period. So to be more specific, on the left, for each subsequent time frame, we see change and persistence in red and gray. On the right, for instance, I guess we see how accessible plot density changes over time. And that information of change and persistence, that binary information, is projected on them. It means for each plot, we have more than 25 different urban form descriptions and their plot building street character and their performance in terms of change or persistence. So independent variables are numerical, urban form measures, and dependent variable is binary, like change or persistence. And this data structure shapes our approach in terms of statistical analysis, as we have numerical and categorical variables. I guess the most straightforward method could be applying a t-test, allowing us to compare two different populations, like basically plots accommodating change or persisting over time, and comparing their average values in terms of the identified urban form. The second approach, and maybe a more robust one, could be logistic regression. It answers the same question from a bit similar but different way and increases the robustness of the findings. It just looks at the probability of change and persistence given the urban form measures. Let's say by looking at the plot characteristics, can we measure the probability of change or persistence, etc. So at the end, a multidimensional metrics emerges. I mean, we have multiple case studies, multiple analysis periods, and quite a multiple urban form measures. The statistical analysis help us to see the relation between urban form and change, and to answer, is there a statistically significant relationship between form and change? If yes, what is the type of the relationship? Is it positive or negative? And more importantly, is that relationship consistent across, 200 years of time? This is very important because some variables may correlate with change at some periods, but its relationship could be quite different in the next period. So it is very important to evaluate the consistency of this measurement diachronically. Is it consistently giving us the same relation, let's say in 1800s, 1920s, and 2000s as well? And before sharing the statistical analysis results, I would like to briefly share some descriptive maps and statistics because they are quite informative to understand how these different cities evolve over time. Currently, we are looking at how plot sizes change over time in 3 cities. Usually, we observe that fine-grained small plot structures were gradually replaced by coarser and bigger ones, especially in New York and Melbourne. Barcelona seems more stable in that regard. Quantitative profile of each city confirms that New York gradually loses its many plot subdivisions over time. On the other hand, in Barcelona, the average plot size is quite stable over centuries. I guess this is the shape of the plots by relying on the plot frontage quality, like narrower plot types gradually replaced with broader and spacious ones. The darker means the broader, the lighter means narrower in this peak. And again, in New York and Melbourne, we have a substantial change in plot shapes, but Barcelona is well preserved comparatively. Density graphs also help us to capture where plot types kind of agglomerate. These small peaks, especially in Barcelona, for example, these ones, capture the unique chamfered corner plots. So visual and descriptive statistics help us to uncover these issues in complementary terms. These are how 2-dimensional building coverages are changing over time. It could be hard to depict some patterns by just only looking at the visual patterns because they seem quite close to each other. But when we look at the quantitative profiles, they reveal that they can capture very local dynamics where new FAR rules and zoning rules applied led to the small downs and peaks in all these cities. Without extending it too much, finally in streets, we have a more stable series of images, as you can imagine, showing that street structures are very persistent compared to other urban form elements, not only compositionally, but also in configurational terms as well, in terms of centrality values too. So they change quite slow, comparatively slow. If we exclude the natural effect of cities' growth and expansion, centrality values remain similar across ages. Only in Melbourne we see some important deviations, and it is again capturing a very, very unique and local dynamic, which is the gradual emergence of and partial loss of laneways. There are some laneways in Melbourne's street structure, so these help us to test whether the measures are reliable enough in capturing the local dynamics or not before deducing some findings from the analysis. And coming to the impact of urban form on physical change and the results of the statistical analysis, we lately published an article in Environment and Planning B discussing the findings within the framework of Midtown Manhattan. As you can imagine, it could be a bit unpractical to present all case studies in a single paper. I mean, struggled a lot to do that. So we decided to just give the results on Midtown Manhattan by focusing on the methodology. And the most important finding is configurational descriptions are more reliable than conventional geometric descriptions in explaining patterns of physical change, while geometric variables like size and shape are often off the mark. Novel access-based measures can accurately describe the relationship in a consistent manner. I will try to open up a bit. I mean, to be more specific in terms of plots, the most prevalent hypothesis we have in the literature is size and shape of a plot is a determinant factor, like small plots are persistent, larger ones change faster. All studies we reviewed use these two plot measures in the current literature. So our findings illustrate that there's no statistically significant and consistent association between individual quality of size and shape and physical change. At that point, I should note that previous studies were conducted in kind of similar settings like suburban residential neighborhoods or historical medieval cities, and they identify some positive relationships at some periods. But when I evaluate the situation across ages in diachronic sense, I see that these relations are sometimes positive, sometimes negative, and sometimes not even statistically significant. So by looking at the individual plot quality, I can say that we cannot say its performance in terms of physical change. What is more important is contextual character of plot structures, like what kind of setting is that plot sitting or located? Is it closer to smaller plots like itself, or for instance, is it surrounded by larger plots? That has a quite influential effect on physical change. So not individual plots, but plot patterns are quite informative in, let's say, in quotation marks, predicting physical change patterns. Accessible plot density, the measure that I mentioned, exactly captures that quality within an accessible catchment. We find that fine-grained plot structures characterized with high APD values are more persistent compared to coarser-grained ones. So instead of individual plot characters, we need to focus on character of plot structures within accessible reach. That is informative to understand the physical change. I guess this is very similarly accessible plot frontage values. Again, quite consistent and significant association have been found. Areas characterized with narrower plot structures change physically less compared to broader ones. Again, I should emphasize that this is not individual plot shape, but the overall shape character of plot patterns. That's the one which is significantly associated with physical change. Accessible plot size diversity is an interesting variable measuring how sizes of plots are diverse within a catchment area. Is it homogeneous or heterogeneous? We also find a positive relationship indicating that diverse and heterogeneous plot subdivisions change more often compared to homogeneous ones. It's a notable finding to understand the effect of diversity on spatial dynamics. In terms of the effect of buildings on physical change, I guess one study, Whiteend and Carr's study in 1999, was arguing that number of dwellings per hectare has an effect on physical change on London suburbs. I think that's a bit primitive density measure, saying basically nothing about the form of the density. So we took this a bit further and tested with these novel and informative density measures like GSI and FSI. And the findings illustrate that there's a negative relationship between build density and physical change. Obviously, it is quite intuitive to argue that the more the area, was underexploited in terms of build density, the more room it leaves for physical change. So empirical findings confirm that intuition too. In terms of street centrality, most of the configurational studies, such as space syntax, argue that character of streets are very influential for the structure of cities and how they function and how they develop or change over time. Studies originated from this particular space syntax lab, such as Professor Vaughan's Adaptable Suburbs or Professor Sam Griffith's studies combining Consenian and space syntax studies, confirmed that centrality is quite influential on physical change patterns. We can also confirm that we found local centrality measures have a positive relationship with physical change. Buildings along more central streets change physically more often compared to isolated ones. Global centrality measures were not found to be associated, but I guess that could be quite normal as I'm not doing the change analysis globally for the entire city. The scope is a bit limited to the city centers. So in that limitation, I mean, local centrality measures are working perfectly fine to predict physical change. However, there are some exceptional periods where centrality does not effectively capture that relationship. For instance, in New York, until early 1900s, there were elevated railways in Midtown, and these elevated lines discouraged physical redevelopment because they were causing noise and air pollution along these very central streets and making them less attractive areas, even if they are highly central. As soon as these elevated structures are demolished, we found a very significant relationship between street centrality and physical change. I guess it shows contextual conditions of streets are also important variables that should be considered. I guess that supports Neto's previous warnings about the contingent circumstances on street centrality. So very briefly, in this specific article, we demonstrated that, configurational measures capture the relational dimensions of urban form that geometric measures cannot. And we need to validate existing hypotheses within more dynamic urban settings that has been overlooked, I guess, in urban morphology. And we also provided some empirical evidence for the hypothetical influence of diversity on urban form resilience. And we also provided some empirical support for the streets' influence on physical change patterns. Shortly, in another recently published article, this time we want to go a bit further than, doing a correlation analysis and to develop plot typologies to see if they could predict physical change. Without a further repetition, we basically utilize these three fundamental plot measures of accessible plot density, accessible plot frontage, accessible plot compactness in walkable 400 meters distance. And then we employed a k-means cluster analysis to identify plot pattern types having distinct character in terms of these three measures. Skipping the technicalities of k-means for the ones who are not familiar with the method, it basically sorts our data points, meaning plots, according to their resemblance or difference to each other. The analysis resulted in 4 dominant types, from fine grain to medium to large, from narrow to broader plots, or from compact to medium compact. Low compact types we couldn't find because they are mostly grid cities, and plot shapes are usually quite compact and rectangular. And diachronic mapping of plot types along with some statistics are highly informative just in itself, which plot types emerged in which periods, where coarsening process started. For instance, in New York, it started along this Fifth Avenue region, very close to the Grand Central Station. Then it kind of dispersed like a disease to the rest of the Midtown Park Avenue area with its, Rockefeller Center and high-rise, distinct building typologies sitting in coarse-grained plot structures, etc. And in Melbourne, it also captures very unique local dynamics after 1970s, after the third period. There's a harsh and drastic transformation process in Melbourne's CBD, which left, coarse grain and very homogeneous plot structure in the city center. And in Barcelona, compared to the other two, plot structure is highly stable and persistent. Physical changes have been accommodated within the existing plot boundaries, interestingly. The reason is height limit rule, which discourages plot amalgamation and gaining extra floor space just for that. So these conservative rules are discouraging the loss of plot subdivision in Barcelona, mostly. And we run this time chi-square analysis to see if there's a statistically significant relationship between plot categories and change persistence. The results are positive. The graph below demonstrates which plot type, changes or persists at what degree. As you can see, while finer grain, narrower and compact plots change less compared to the coarser grain and broader and medium compact plot types. Medium types are sitting at the medium level mostly. So the analysis confirms this relationship via plot types this time and demonstrates configurational morphometrics are very informative in this sense to develop some, let's say, quantitative typologies and measuring their relation with various processes. Just to conclude, there are a few empirical contributions, like providing an empirical support for the role of urban form in guiding spatial dynamics, and we had a chance to test and confront some prevalent hypotheses, especially the ones focusing on geometric descriptions with this novel data set. And we also validated some of the well-known arguments like the influence of street centrality on physical change dynamics. And I guess the most important methodological contributions are the utilization of an integrated framework in terms of the Consenian and configurational perspectives, and first-time operationalization of novel access-based urban form descriptions in understanding spatial dynamics. And 3 distinct unique data sets are about to be also published in open access repositories to contribute to open science perspective. In terms of the theoretical contributions, the study shows that I guess design does not exclude the possibility of bottom-up evolution. Urban design may work as an enabler of open-ended evolution and change if we can discover and provide sufficient simple conditions. And more importantly, the way we design the built environment may limit or expand future possibilities. There are inevitable limitations, as all studies have. Available periods and, let's say, snapshots are limited with cartographic data, so we need more fine-grained longitudinal data sets. Currently, I guess Google Earth or other Earth observation services provides, make it possible to go back until the beginning of 1800s or, to 2000s. So more data probably will be available in the next decades. Digitization of cartographic resources is an immense challenge, I believe so. And the main reason of the scarcity of these studies, I took that challenge and did a laborsome task by digitizing as much as I can within a limited time. But obviously we need more longitudinal data sets in this particular field. So to conclude, I can reiterate this research kind of traveled between the interfaces of these 3 domains of knowledge. Each interface exposes future research needs and you understand how cities are structured and evolves over time. And you understand how design conditions affect change and persistence with a more time-conscious and evidence-based approach. And it will, I guess, eventually should serve for scientifically well-informed urban design and planning instead of intuitive understandings. So without further ado, let me stop over here. Thanks for your attention and time.